Hello, this is Professor Brown-Sederberg, and I'd like to demonstrate the use of sentinel values. A sentinel value is a value that's used to signal something. And typically in programming, it's used to signal the stop of the input of information. Very often that input being gathered from a user. And that's what I have in this program. This program is intended to gather information from the user about costs of items. The user signals that they're done entering information by entering in a negative cost. I'll then print to the screen the total of those costs as entered by the user, not including the negative value entered by the user to signal the end of the processing. So here we have declared a variable type scanner called keyboard and created it. We've declared a variable of type double called cost, another sum, and sum's been given an initial value of 0. I need sum to have a value of 0 to start off because I'm going to be adding to sum the costs as they're entered. So here we have what's a priming read. I ask the user to enter in an item cost and to enter in a negative number if they want to exit. These two lines are a priming read. They allow the user to enter in a positive number if they want to enter in numbers, costs, or to enter in a negative number to signal that they have no costs to enter. The user enters in a value. It's gathered through this call to next double and stored into cost. Now, cost is the variable that we use in the control of the while loop. That is to control the entrance and the continued iteration through the loop. So here we see that our test is as long as cost is greater than or equal to 0. That is, a positive number has been entered. If that's true, we enter the loop. And in this loop, we add to the value in sum, the value in cost, and overwrite the memory space sum. We then ask the user to enter in another item, the cost of another item, a negative number to exit. We gather that number, that input from the user, through next double, stored into cost, and come up to the top and test if that value entered is indeed greater than or equal to 0. We'll continue to iterate through this loop as long as cost is greater than or equal to 0. When cost is no longer greater than or equal to 0, we'll exit the loop and execute this line that prints out the string the sum of the items entered is and the value of sum. Now, let's compile this program and then run it. And we see that the user's asked to enter a value, and this is here. I'm asking, this is my priming read. So let me enter in 20. That value is greater than 0, and so I'm in the loop. At this point, I have executed this line. I've taken the value in sum, I know that's 0, added the 20 entered by the user, and put it into the space called sum. I then can see that I'm asking the user to enter an item cost, negative number to exit, and I'm here. So let me enter in 30. 30 is gathered, tested here. Cost is 30. It is greater than or equal to 0. So now the value of cost 30 is added to what's in sum. We know that's 20, and stored into sum. So sum now has a value of 50. I'm here in the loop being asked, would you like to enter an item cost or a negative number to exit? And I'm going to enter in a negative number. I'll enter in -1. So I exit the loop, and we've executed this line. That the sum of the items entered is, and it's 50, and we know that's correct. This is an example of the use of a sentinel. The sentinel is this value of cost. If the user enters a negative value for cost here on this request, this loop is not entered. If the user on this request enters a positive number, the loop is entered, processing takes place, the user is asked again, and we test here the value entered by the user on that request. And we'll continue through this while loop as long as the user enters in a value greater than or equal to 0. Now, one important thing I want you to note. It's very important that I have this line, sum equals sum plus cost, here as my first line in this while loop. since I have constructed this program with this priming read. Had I not placed my sum equals sum plus cost here, but rather here as the end line, we'll see that I have a very different result. So let me compile this program, and now let's run it. And I'm going to enter those same values. So I'll enter in a 20, now I'll enter in a 30, I'll enter in a -1, and we see that the sum is printed 29. We know that that's an incorrect value. We know that that's an incorrect value because I entered 30 plus 20. Those should be added and printed to the screen. The -1 is just my Sentinel. So what's happened here? What's happened is, with this sum equals sum plus cost here as the last line and not here, the user entered as I did. Remember, I entered in a 20 as my first number. So I entered in 20, that was the value of cost. I was then asked to enter another value. I entered 30, so the value of cost is 30. That cost, 30, was added to sum. Sum has a value, remember, of 0, and so 30 is the value in sum. We then came back up. I'm asked to enter another number. I entered -1. -1 is the value of cost. That was added to the value in sum, that's 30, stored into sum, and I came back up. Now, the cost entered here, my -1, is what's tested here, and the Sentinel worked. Once the -1 was entered, I was out, but that -1 was included in the values used to calculate sum. And it was because I did the calculation after this, the enter by the user of a number, the Sentinel value. I can't have my sum equals sum plus cost here. I must have it here. Otherwise, I'll be including in sum the Sentinel value. I can't have my calculation after the Sentinel value's been entered before it's tested. So you see here, I'm entering it, testing it. If I had this situation, I'm entering it, using it, testing it later. So if you're using a Sentinel value, that's how we do it. We have a value that signals processing, usually the termination of processing. And the way we correctly write this program using a Sentinel value to allow the user to signal the stop, the end of input of information, and to have the appropriate value printed here as the value of sum, we have this as our loop. So this is a demonstration of the use of a Sentinel value.